Hello, my name is Ardi and we are going to solve problem E3.2. Here, find all the node voltages in the network of figure E3.2 using MATLAB. I think we don't need to use MATLAB. I just use calculator here. And let's do it. First thing that we need to do is to assume the direction of the current. For the branch with the current source, I just follow the arrow. And this one here, and for the others I just assume arbitrarily. So I just assume this going to the right, this also going to the right, this also going to the right, and this is going down. And all we need to do is we need to do KCL at node V1, and then at node V2, and then at node V3. Okay, let's exactly do that. The first thing that we need to do is to do KCL at node V1. What does KCL say? KCL said that the sum of the current that goes in will equal to the sum of the current that goes out. The only current that goes in is this one here, and that value is 4 milliampere. Good. And then we will have the currents that goes out, which is this one. So we will have V1 minus V2 divided by 2. Okay, and then what else? We will have plus this current also going out, so we'll have V1 minus V3 divided by 1. So we'll have V1 minus V3 divided by 1. And I want to get rid all of the denominator here, and that can be done by multiplying both sides by the general common divisor, least common multiplier of this 2 and 1, which is 2 here. So we'll have 8, and we will have V1 minus V2, because 2 and 2 will cancel each other. And 1 and 2 will becomes 2, so we will have plus 2V1 minus 2V3. Good, let's simplify things here. So we will have V1 plus 2V1, that will be 3V1. Okay, and we only have minus V2. And for V3, we only have this minus 2V3. All of that will equal to 8, and nothing that we can do further from here. Let's just save this as equation number 1. Good. And now let's move on to the other nodes. So now let's do KCL at node V2. Let's do exactly that. KCL at node V2. Again, we have KCL is the sum of the current that goes in will equal to the sum of the current that goes out. Good. The only current that goes in is this one, and that current is V1 minus V2 divided by 2. Good. And then this current is going out, so we will have this will be V2 minus 0. The voltage in a ground will be 0, right? And V2 minus 0 is just V2. We'll have V2 here divided by 1 kilo ohm. So we'll have 1. Okay, and then this one here, so we will have plus V2 minus V3, V2 minus V3 divided by 4. Okay, let's multiply this by the LCM of 2, 1, and 4, which is 4, right? 2 and 4 will cancel into 2, so we will have 2V1 minus 2V2. And then this will be 4V2. And then we will have V2 minus V3. Good. Now we will have 2V1. Okay, we will have minus 2, minus 4, minus 1. So we will have minus 7V2, right? Minus 7V2. And then minus V3, let's move it to the left-hand side. So we will have plus V3. Good, all of that will equal to 0. And nothing that we can do here. Let's save this as equation number 2. Okay, we have two equations now, but we have three variables. We need one more equation, which can be obtained by using KCL at V3. Let's do exactly that. Let's play the same game again. So we will have KCL at V3. KCL at V3. KCL said that the sum of the current that goes in will equal to the sum of the current that goes out. Okay. And there are two currents that goes in here. So we will have this. So for this one, we will have V1 minus V3 divided by 1. And then this one here, we will have plus V2 minus V3 divided by 4. And all of that will becomes 2 ampere because this is the only current that goes out. Okay, multiply both sides here by 4, so we can get rid of the denominator here. So we will have 4V1 and then minus 4V3 and then plus V2 and then minus V3 because 4 and 4 will cancel into 1 and 2 multiplied by 4 is just 8. Okay, let's simplify things. So we will have 4V1 and then plus V2 and then minus 5V3. All of that will equal to 8. And let's save this as equation number 3. Okay, so we have 3 equations and 3 variables. Okay, and that is good because we can rewrite this in a matrix here. So we will have 3 minus 1 and then minus 2. And then this is V1, V2, and V3, right? V1, V2, and V3. Okay, and all of that will equal to, this one is 8. Okay, and that is the first equation. The second one is 2, and then minus 7, and then 1. Okay, and that will equal to 0 here. And here we will have 4, 1, and minus 5, and all of that will equal to 8. Good. Okay, now we just need to solve V1, V2, and V3. Okay, we can do that using calculator, but let's clean all of them first. Okay, now let's do calculator. So here is my calculator. You can use this kind of calculator and set it up as equation solver, which is number 5. And we have 3 variables. We use number 2 here. Okay, good. So we'll have 3 minus 1 and then minus 2 and then 8. Good. And then we will have 2 minus 7 and then 1 and then 0. And then 4, 1, then minus 5, and then 8. Okay, so we get this V1 here. The X value is V1. So we'll have 5 point something here. So we will have V1 is 5.1 4286. Okay, 4286, and the unit here will be in volt. Okay, and then what is V2? V2 is 2. Yeah, nice number. V2 is 2 volt. And then what is V3? V3 is, what is V3? The Z value here, which is 3.1429. Okay, 3.1429 volt. Okay, and I think we get this right because that is exactly the same as the answer given in the book. Hopefully I did not make any mistakes. I should not make any mistakes. Okay, thank you for watching. See you in the next video. Bye bye.